Okay, sorry about that. Okay, number 8. It says find the absolute max and minimum values of the over the specific interval. Okay, so we need to find the derivative f prime of x. Okay, and set that equal to 0 to get any critical values. And then I also need to test my endpoints. So this is negative 8x cubed. Let's just write f of x. Plus 9x squared plus 6x plus 6x minus 5. So this is negative 24x squared plus 18x plus 6. Okay, set that equal to 0. Let's divide by negative 6. Okay, so this becomes 4x squared plus 3x plus 1 is equal to 0. Okay, I can factor this. I can factor this into 4x plus 1 and x plus 1. Is that right? No, this would be a minus 1. Yeah, because this would be a minus 1. Sorry. Okay, yeah, that's right. Oh, nope, that's still wrong. 18 divided by negative 6 is a minus 3. So I was right. So this one is plus 1, and this one's a minus 1. Minus 4x plus 1x is equal to 0. So 4x plus 1 is equal to 0. Or x minus 1 is equal to 0. And so subtract 1, and I get 4x equals negative 1 divided by 4. X equals negative 1/4, or x equals 1. Okay. Okay, so we have these two values, but I also have my endpoints to contend with. So these are my critical values. Those are my CVs. Okay, but I also have my endpoints, and the endpoints here are negative 2 and 0. So we also have x equals negative 2 and x equals 0 to look at. So I'm going to plug these values in for my function. And I'm going to actually do that on a calculator. Okay, to make it faster. Clear. Okay, so I'm going to go, I'm going to say that x, oops, that, let me put this back into function mode. Okay, so I'm going to say that, there we go, now I got x, clear. I'm going to say that this is negative 8x cubed plus 9x squared plus 5x, or sorry, plus 6x. 6x, okay, minus 5, okay, and it's going to give me some wacky value, but that's okay. I'm going to say let x equal what? What do we want x equal to? So we can try negative 1/4 first. So that's negative 0.25. Go back to the calculator here and go negative 0.25. I'm going to store that in for x. Okay, and it says, oh, x is now that. So this just saves me from having to rewrite. This just saves me from having to rewrite this over and over again. So if I rewrite this now with that x value, and I hit enter, it gives me this value here of negative 5.8125. That was when x was equal to negative 1/4. So, I mean, I could plug it in by hand if I want to, but again, this is a lot faster. I'm just going to use the technology that I have. So when x was negative 1/4, this thing was at negative 5.8125. Okay, so that's 1 point. Okay, what about when x is equal to 1? Okay, so I'm just going to change the value of x. I'm going to say here that x, sorry, clear. I'm going to store 1 in for x. Okay, so now x is 1. And I'm going to go up here and grab this. And now I get 1 comma 2. Okay, so when x is 1, y is 2. Okay, so that's 1, 2. What about when x is negative 2? When x is negative 2, I'm going to go negative 2, store that in for x. Okay, and then grab this guy from above again. And I get 83. Whew, that's a big number. Okay, so that guy's at 83. So 83. And when x is 0, that one's actually pretty easy to get. It's just negative 5. Because if I plug in zeros here for all of the x values, okay, then everything goes to 0 except for negative 5. But if you really want to prove that to yourself, you could store that in for x. And then you could grab this from above. And we get negative 5. So what's the smallest value here? Smallest value is negative 5.8125. This would be my minimum. And what's the largest value? It's at 83, which is my maximum. Okay. That's number 8. Okay, somebody wanted 17 next. Okay, let's see what 17 says. Okay, from a thin piece of cardboard, 81 by 81, square corners are cut out so that sides can be folded to make up an open box. What dimensions will yield a box of maximum volume? What is the maximum volume? Okay, so let's zoom in here. Let's go 17. Okay, so we have basically an 81 by 81 piece of cardboard. Okay, and we want to cut out squares so that when we fold these up, it's going to make a box. And I want to know what, what dimensions will yield a box of maximum volume. Okay, so I'm going to call this X and 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 X. Okay, so it looks like the length and the width here of the box, if I were to look at the box that's being created here, okay, so the length and the width of the box are basically 81 minus 2x, 81 minus 2x, and then the height is x, right? So 81 minus the 2x gives me these pieces here. So if I just focus on the pieces that are going to come together, well, those are 81s minus 2x's. Okay. And so the volume here, V of x, is 81 minus 2x times 81 minus 2x times x. Okay. So I'm going to multiply this out and then find out what does x have to be in order to maximize the volume here. Make the volume be a maximum. Okay, so what's the minimum? Well, the minimum could be, take this so that there's no volume. I mean, the minimum would be making x equal to whatever half of 81 is. And then that's the minimum volume. There's no volume. Okay, maximum is going to be some sweet spot in between a really flat box and something not so flat. Okay, so multiply this out. This becomes 81 times 81. Okay, which is going to be 6561. Okay, and then 81 times -2, that's 168, or sorry, 162 plus 1 is 324. So that's negative 324x. Okay, and then -2 times -2, that's positive 4x squared. Okay, now we're going to multiply this by x. We get 6561x minus 324x squared plus 4x cubed. Okay, that's the volume. Now I want to maximize this volume, so take the derivative and set it equal to 0. 6561 minus double 324, that's going to be 648. Plus, this is going to be what, 12x squared? Okay. Okay, and so set this equal to 0. Okay, so let's see what we get here. So is this guy like 12? I don't think so. Okay, so let's use quadratic formula here. So this is 12x squared minus 648x plus 6561 equals 0. Okay, so x equals plus or minus, or sorry, negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so this is going to be negative of negative is positive 648 plus or minus the square root of 648 times 648. It's a big number, 419904 minus 4 times 12 times 6561 all over 2 times a, which is 12. Okay. So x equals 648 plus or minus the square root 4 times 12 times 6561 is 314928. 314928 all over 24. 419904 minus the answer is 104,976. So minus the square root 109,976 all over 24. So square root that guy, and that's 324. So x equals 648 plus or minus 324 over 24. Okay, nice. Okay, and so x equals 648 plus 324, 972 divided by 24, 40.5, or 40.5. Okay, or 648 minus 324 divided by 24 is 13.5. Okay, so either x is 40.5 or 13.5. Well, this guy is going to give me my minimum, and this guy is going to give me my maximum. Why? Because what were the sides? The sides were 81 minus 2x, right? We'll plug this guy in. You would get 81 minus 81, and that would be 0. So your length would be 0. That's your minimum. You're not going to have any volume whatsoever. Your maximum, however, is going to come from this guy here. So what are the dimensions going to be of my box, right? What are the dimensions of my box? Well, the dimensions are going to be whatever 81 minus 2 times 13.5 is. 81 minus 2 times 13.5 and 13.5. So what's 81 minus 2 of these? That's 81 minus 27. I feel like I should know that. It's 54. Okay, so this is 54. So it's 54 by 54 by 13.5. And so those are my dimensions. And then what is that? What's 54 times 54 times 13.5? It would be 39,366 cubic inches. Okay, so these are inches as well. Okay, that's the answer that I got earlier. So I'm going to go with it.
Excuse me, can I see a little bit up from your calculations, please? Thank you.
Sure. Okay, let's see what people are asking for next. 20 is next. Okay. Okay, now. Okay, 20. Find dy. Okay, find dy and then find dy when dx is equal to 0.01. So dy here. So dy dx is equal to the derivative of this thing, right? So 2x squared minus 1. All right, well, let's just do y first. Y is equal to this. So what's y prime, or dy dx? Well, this thing is going to be dy dx. The square root, the derivative of square root is 1 over 2 times that square root. Now we have to do the chain rule on this. The chain rule is the derivative of the inside portion is going to be 4x. So that's 4x. I'm going to just put that on top because 1 times 4x is just 4x. Okay. And so now they're saying, well, just what is dy? Well, multiply both sides by dx. And dy is equal to 4x, but what are they telling me x is? X is 5 over 2 times the square root of 2 times 5 squared minus 1 times dx, which they're telling me is 0.01. Okay, so this is going to be 20 over so this is 20 over, this is 2 times the square root of 25 times 2 is 50. 50 minus 1 is 49. Okay. And this is going to be times 0.01, which is 1 over 100. Okay. So that cancels, becomes 10. This cancels and becomes 10. This square root becomes 7. And so I get 7 times 10, which is, so this is 1 over 70. Okay, and then you could come up with some sort of decimal approximation to that if you want. Okay, so this is what dy was, by the way. That was dy. Okay, so that was 20. Okay, so that's 1/70th, or 0.0143. It's really 0.0142258 something like that. This is 1 divided by 70. 2857. Yeah, 2857. Okay. Close enough. Okay, so somebody asked for 21 as well. You guys are making me do all the hard ones. Oh, that's good. That's good. Okay, better me than you. Okay, so 21 here is the elasticity of demand. Okay, let's make sure we know how to do elasticity of demand. There will be a question on elasticity of demand. There are 10 questions, but the first 5 have like multiple parts. So like multiple parts, like 10 questions for the first 5. And then it kind of slows down from there. So 10 questions for the first 5 and like 1 question for the last 5. So, yeah. Okay. So economics, we have dp, q equals dv. If you want to make p be x, if it messes with your mind to have p there, just make it an x. Okay. Maybe yours has an x, I don't know. At some point, I think I changed it, but maybe not. I don't know. Okay, it doesn't really matter what those people are doing outside. Okay, so That's the quantity, that's the demand function, right? So find the elasticity. Okay, so what is the elasticity here? Well, what was the elasticity function? Wasn't it negative x d prime of x over dx? Something like that, right? Okay. And so, well, what is d of x? What's d of x here? Well, d of x is equal to, what is d of x? D of x was 600 over x plus 5 cubed. Okay, 600 over x plus 5 cubed. 600 over x plus 5 cubed. Okay. So I could really rewrite this if I wanted. Get rid of this stuff from the previous problem. Okay, I could really rewrite this as 600 times x plus 5 to the negative third power, because I want to take a derivative of this. So what's the derivative of this thing? Well, it's going to be 600 times, bring down the negative 3. Oops, come on, this thing is delayed. 600 times negative 3 x plus 5 to the negative second power times the derivative of the inside. But what is the derivative of the inside? Derivative of x plus 5 is just 1. Okay, so this becomes what? Well, this becomes, I'm just going to put it together this way. So e of x is equal to negative x times d prime of x. Well, that's negative 1800 times x plus 5 to the negative second power. Okay, remember this is all being multiplied. Cool. Okay, so that's x and it's a negative. I guess I don't need the parentheses. Okay, all over the original function, which is 600 times x plus 5 to the negative third power. Okay. So what happens here with these negative exponents? Well, they swap. They swap positions. So this is negative x times negative 1800 times x plus 5 to the third over 600 times x plus 5 to the second. Okay. Well, if it's a negative on the bottom, it becomes positive on the top. And if it is positive on the bottom or negative on the top, it becomes positive on the bottom. So just a rule from algebra, from college algebra. Okay. And so this negative, they're going to cancel out and just make these positive. So I'm going to do 1800 x, okay, over 600, right? Okay, well, what's 1800 divided by 600? That's 3. So this just becomes 3x times, and then what is x plus 5 to the third divided by x plus 5 to the second? Well, that's just x plus 5 to the first. 3 minus 2 is 1. X plus 5 to the first, which is just x plus 5. So I can actually distribute this, and I would get 3x squared plus 15x. Okay, and that's what e of x is. So that's part A. Like, woohoo, got through part A. Yes, we did. Okay, part A. Part A. Forget it. Okay. Shouldn't be to the negative fourth.
Professor,
Should it be?
Professor,
Yeah.
for d prime of x.
Oh, you're right. You're right. It should be negative fourth power. Sorry. So, because we go from a negative third to a negative fourth. Is that right? Yeah. Okay, so this should be negative fourth power. Yeah. Negative fourth power. Okay, so yeah, so we still get 3x on top. But this is a third on the bottom and a fourth on the, or third on the top and a fourth on the bottom. So we end up with x plus 5 on the bottom. Okay, there we go. So that's what e of x is, or what they're calling e of p. Okay, so that's part A. Okay, part B says, find the elasticity at x equals 8. Well, just plug in 8. So e of 8 is going to be equal to 3 times 8 over 8 plus 5, which is going to be 24 over 13, which is greater than 1. So this is elastic, okay, because it's bigger than 1. Okay, C says find the elasticity at 2. So this is going to be 3 times 2 over 2 plus 5. This is going to be 6 over 7, which is less than 1. And so it's inelastic. Okay, inelastic. Okay. D. At a price of $8, will a small increase in price cause the total revenue to increase or decrease? Well, at $8, it's elastic, which means that the revenue will be decreasing. Remember over here, if it hasn't meet if the revenue hasn't meet its maximum, then over here it's inelastic, and over here it is elastic, and so it means that the revenue is on the downward, it's going downhill, and so this is going to decrease revenue at $8. Okay. And the last one, find the price at which revenue is a maximum. Okay. I want to know, well, when is E of x equal to 1, right? It's a maximum when the elasticity is equal to 1. So 3x over x plus 5 is equal to 1. Okay, I could just multiply both sides by x plus 5. That would leave me with 3x equals x plus 5. Subtract x. I get 2x equals 5, or x is equal to $2.50 when I divide by 5. Okay, so we would say that E of 250 is equal to 1, which will maximize revenue. Okay, I think 23 was next. Okay, so let's go over 23 here. Okay, minimizing average cost. The total cost in dollars of producing X units of product is given by blank. How many units? Okay, total is given by how many units should be produced to minimize the average cost. Oh, okay. So let's minimize this average cost function. So C prime of X is going to be equal to what? 50 plus 50 over 2 radical X plus 1 over 50. Okay, this radical X cubed is really, this thing here is really X to the 3 halves. So if I take the derivative of that, that's going to be 3 halves X to the negative 1 half. Okay. So this is going to be 50 plus 50 divided by 2. I'll just leave that for right now. This is 50 over 2 radical x plus, this is 3 over 100. And this x to the negative 1/2, that's radical x. Okay. See where we're going here. Oh, you know what? I screwed up. I'm sorry. Thank you. Okay. Why did I screw up? Well, here's why I screwed up. Because it asked me for minimizing average cost. Okay, we want to minimize average cost. So the first thing I actually have to do is we actually have to take c over x and divide it by x. So we need to divide everything through by x. So this really is c of x over x, which is going to be a of x for average cost. So we're going to divide everything by x. So this is 50 plus, this is 50, I'll put it, I don't know how many steps to do here. Everybody understand that this is 50x over x plus 50x to the 1/2 over x plus, okay, x to the 3/2 over 50 over x. Okay. So this becomes 50. This becomes 50 over, this is 50x to the negative 1/2, because 1/2 minus 1 is negative 1/2. Okay, this thing, I can think of it as a fraction over a fraction, x over 1, and that gets flipped upside down. So this is basically plus, okay, x to the 3/2 over 50 times 1 over x. Okay, so dividing by a fraction is multiplying by the reciprocal. So this will be 3/2 minus 1. Well, 3/2 is 1 and 1/2. Minus 1, it's just going to give me 1/2. So this really becomes 50 plus 50x to the negative 1/2 plus 1 over 50 x to the 1/2. Okay. So now I need to take the derivative of this guy. Okay, so taking the derivative of this guy, this thing goes to 0. Okay, this becomes 50 times negative 1/2 x to the negative 3/2 plus 1 over 50, and then this becomes 1/2 x to the negative 1/2. Now I want to set this equal to 0. Okay, let's set that equal to 0. Okay, so this is being, that's a 0 there. Okay, so what do we got here? We've got basically negative 25 is 50 divided by 2 is 25. Such a delay. Okay, and then this is x to the 3/2 in the denominator, plus this is 1 over 100 times x to the, this is 1 over x to the 1/2 is equal 0. Now, I want to kind of clear the fractions here if I can. So what I'm going to do is I'm going to multiply both sides by 100x to the 3 halves. Okay. So, okay, and what that's going to allow me to do is that's going to allow me to, well, I won't skip steps. Okay, since some people are not as good as others at following the numbers. Well, this is going to be 100x to the 3 halves times 1 over x, sorry, 1 over 100x to the 1 half is equal to 0 times 100x to 3 halves. Okay, but that's just going to go to 0. Okay, so when I multiply this out, I get negative 2,500. And what happened to the x to 3 halves? Well, it canceled. This cancels with that. Okay, and then what happens here? Well, this is plus 100. And then what's x to the 3 halves divided by x to the 1 half? Well, that's just x to the 1. Okay. Okay, that's x to the 2 halves, basically, which is 1. And this equals 0. Oh, nice. Okay. Okay, so add 2,500 to both sides. And I get 100x is equal to 2,500. Divide by 100, and I get x equals 25. That was nice. Okay, and so it says, okay, the total cost in dollars, okay, of producing X units why did it come out like that? Oh, you know what? I screwed up. I forgot to cancel off the 100. It shouldn't be 20. It should. This should be. This should just be X. So that should just be X. So the first, bring that over, and that should just be X. Yeah. Because I was multiplying here by 100 because I needed to cancel the 100. Yeah. And so X is equal to 2,500 units. Okay, so that's the value of X that will do what? Minimize the average cost. Okay, so 2,500 units will minimize the average cost, which we said was C of X over X, or we called A of C of X. Okay, so that will minimize the average cost. Stop. Be nice to me. Be nice to me. Okay, I'm going to unplug your batteries. Okay. Okay, so what number was that? What number did I just do? Oh, 23? Okay, so 22. So Maria says 22. Okay, yeah. Okay. So where are we at? Okay, so 22, yeah, I'll do 22 right over here. Okay, 22. Okay, so 22 says differentiate implicitly to find dy dx, and then find the slope at 2, 3. Now keep in mind this is x and this is y. 2, 3 is x, y. So when x equals 2 and y equals 3, we want to find dy dx. So what is this? This is 5x squared minus y cubed is equal to -7. Okay, so let's implicitly differentiate this. Come back to me. Any day. Any day now. There we go. Go up. There we go. Okay, so what's the derivative of 5x squared? It's 10x. What's the derivative of negative y cubed? Now this is y with respect to x. So this is negative 3y squared y prime is equal to 0. So what is y prime? Well, y prime we could call dy dx. So I'm just going to solve for y prime and let that be dy dx. Okay, so let's subtract 10x from both sides. We get negative 3y squared y prime is equal to negative 10x. Divide by negative 3y squared. And I get y prime is equal to 10x over 3y squared. Okay, so this is dy dx. Okay, is equal to y prime. So 10x, well, what was x? X was 2, and y was 3. This is 3 times 3 squared. Well, this is going to be 20 over 27, which is the slope of the tangent line, you know, of this function, whatever this function does. Okay, it's going to have a slope, okay, at the point 2, 3. So at the point 2, 3 there, it's going to have a slope of 20 over 27. That's the slope of this tangent line. That's what the derivative is. It's the slope of the tangent line. Okay. Okay, Dominique says 18. Okay, let's go over 18. Okay, inventory costs. Is that, did I really put one of those on here? What is 18? Yeah, inventory costs, just get rid of that. It's not on the exam. Okay, don't waste your time doing that one. Okay, it's too involved a problem for an exam. So, thank God. Yeah. I think I even told you when I was going over it. I'm like, I'm not going to put this on the exam. Yeah. Oh, here's the answer. Wait, those aren't the answers. Okay, well, 16. Let's go over 16. Okay, 16 is 16. Okay. Business maximum profit. Okay, yeah, let's go over the maximum profit here. Okay, business maximum profit. Okay, so well, what is profit? I mean, let's just get our profit function. Let's get, it says find the maximum profit and the number of units that must be reduced in order to yield maximum profit. Maximum profit. Okay, so P of X is equal to R of X minus C of X. So this is just going to be the top minus the bottom. So 0.8 minus 0.2 is negative 0.4. 160 minus 20 is going to be positive 140. And then 50 minus 60 is negative 10. Okay, so now what I want to do is I want to find out, well, what's P prime of X here? What's the derivative equal to? And that's going to be negative 0.8x plus 140. Set that equal to 0. Okay, and so solve for X. This actually isn't too bad. 0.8x equals negative 140. Divide by negative 0.8. And X, if I plug that into a calculator, 140 divided by 0.8 is 175 units. Okay, so X is the number of units that will maximize this, and then what is the find the maximum profit? So what's the maximum profit? We'll just plug in P of X, P175. Put this X value in. So this is negative 0.4 times 175 squared plus 140 times 175 minus 10. Okay, so what's 175 times 175 times 0.4? That's 12,250. What's 140 times 175? That's 24,500 minus 10 minus 12,250 is 12,250. That's interesting. Minus 10 is 12,240. I'm getting. Yeah. So this equals $12,240 is the maximum profit. Max profit. Oh, okay. Answers. I have them right in front of me. Pick one for me that you think I should solve. Okay, let's see. How about number 5? Can you do number 5? Let's do number 5 real quick. Okay, it says sketch the graph of each function List any extrema and indicate any asymptotes or points of inflection. Okay. Well, there are no asymptotes here. In order for them to have an asymptote, you'd have to have a denominator. Okay, this is just a polynomial function. Okay, but it is going to have mins, it's going to have maxes, and it's going to have concave up, concave down, and points of inflection, right? Okay, so this down here. Hello. Go up. So negative 8x cubed plus 9x squared. Negative 8x cubed plus 9x squared. Squared plus 6x minus 2. Plus 6x minus 2. F of x. Oh. Okay, so let's take the first derivative. Okay, actually, let's not do that. What happens? Well, I can't do that either. Never mind. Yeah, let's just take the first derivative on this one. Yeah, the other way is going to be really tough. Okay, so this is negative 24x squared plus 18x plus 6 is equal to 0. Okay, set that equal to 0. It's going to give me my critical values. Right? Okay, and so this will give me my relative mins and maxes. I'm going to divide this thing by negative 6. Okay, and that gives me 4x squared plus 3x minus 1. Or sorry, minus 3. We did the one similar to this. And another problem, 4x squared minus 3x minus 1, okay, is equal to 0. Okay, so the critical values, yeah, the one where we did the absolute extremes had the same function, but it was from between negative 2 and 1 or something like that. Okay, so what are my critical values here? My critical values are going to be at 4x plus 1 times x minus 1 is equal to 0. So x, remember, was equal to negative 1/4, and x was equal to 1. So those are my critical values. Okay. So when I plug them in, x equals negative 1/4, I would get, plug it into that value, negative 1/4. And I think this was negative 5.1825 or something like that. I have it stored in my calculator here. Let's see what we got. Nope. Come on. Oh, it was in this calculator. I thought it was stored, not my calculator. This guy here. This is not working. Hello, hello, Mr. Calculator. Want to come back to life, please? I guess not. Oh yeah, negative 5.8125. That's what it was. Negative 5.8125. 8125. Okay, so that's one extrema. Okay, and then what's another extrema here? Okay, when x equals 1, I'm at positive 5. Okay, that's another extrema. Okay, so now what we're going to do is we have f prime. Okay, so we have f prime of x was equal to negative 24x squared plus 18x plus 6. And I'm going to take the second derivative now to find my point of inflection. Okay. And then, okay, and so f double prime of x is equal to, this is negative 48x plus 18 is equal to 0. So set that equal to 0. This will give me my point of inflection. So this is going to be negative 48x equals negative 18. Divide by negative 48. And x is equal to negative 18 over 48. Both those are divided by 6. Negative 6. So this is 3 over 8. Okay, so x is equal to 3/8. If I plug that back into the original function, 3/8. Okay, I'm not going to do it here, but you will plug it back into this function here, the original one. Okay, I would get f of 3/8 is equal to 35 over 32. 32, okay, which is like 1 and 3/32. 1 and 3/32, so a little bit more than 1. Okay. One and 3/32. 1.09375. Okay, so where's my point of inflection? It's at 3/8, which is 0.375, and 1.09375. This is my point of inflection. Okay, so how the heck is this going to help me get my graph here? Okay, well, this is a cubic. This is a cubic. Normally cubics go like this. But this one has a negative in front, so it's going to get flipped upside down. So it's going to go like this. Okay, this is a positive cubic, and this is a negative cubic. Okay. So I know that I've got a minimum at negative 1/4, negative 5.8. So negative 1/4, okay, is really close to this graph here. Okay, negative 1/4 and negative 5.8. Was that 5.8? Can't remember now. Whatever 45 divided by 16 is. 45 divided by 16. Something like that. No, it's 2. It's 2.8. Well, this one was different. It's 2.815. So this is actually negative 2.815. I thought it was the same as the one before, but it's not. The other one had a -5, and this one has a -2. So this one is negative 2.8125. Okay, so this is negative 2.8125. Okay, so negative 1/4, and then negative 2.8 is going to be somewhere around here. Negative 1/4, and that's going to be a minimum value. Okay, so it's going to come in here, like that, and then go through there. What's the y-intercept? Well, the y-intercept is -2, right? Okay, so it's going to go through there. -2 for the y-intercept. Oops. No, darn it. Not making me happy. gonna have to redraw it. Okay, so this is -2, 1/4, and 2. So we're gonna be coming in like so. That's the y-intercept. Okay, I'm not gonna get the x-intercept because those are just gonna be really, really hard. What was the other extrema? The other extrema was at 1 x is 1. What is this guy? I said before it was 5, but that might not be true. No, it is 5. When x equals 1, y equals 5. Yeah, that's right. Okay, so that's 1, 5. So 1, 5 is here. Boom. And that's the relative max. Okay, so it's going to kind of go here. 1, curve up, and then curve back down. Okay. I'm almost done. Okay, and then it's going to go back down. So, and where's the point of inflection? The point of inflection was at where? Was at 3/8 and 1. So the point of inflection is at 3/8, 1. So about right here, this is my point of inflection. Okay. Yeah, I don't think I did. I think there's only 2 graphs on the exam, and one is not a cubic. So yeah, not maybe higher than a cubic, but it's not a cubic. Okay, I'll tell you that right now. Okay. Okay. Well, I'm gonna call it a day at this point, unless you have any more specific questions. And then an exam is on Tuesday. Okay. Okay. Okay, one second, Maria. I'll be right there.
Oh.
Okay, so let's take a look at 15 here. 15. Okay. Okay, we want to minimize this guy. Okay. So find a minimum. I already did 16. Just to let you know. Did I not do it? I did it. Okay. I can do 15, but I already did 16. Oh, 14 and 15. Oh, okay. I think she meant 15 and 16. I said I already did 16, Paul. So, oh, 14 and 15. Oh, okay. 14 and 15. Okay, sure. Yeah. Okay, let's do 14 and 15 real quick. Okay. They're basically the same problem. So let me do 14 because it's the harder of the two. Okay, so we want to maximize, right? So 14. We want to maximize this thing, right? Where, okay, so what I'm going to do here is I'm going to I'm going to substitute for a variable in. So I'm going to solve for y. I'm going to solve for y here. If I solve for y there, I get y equals 30 minus 2x. And I'm going to plug that in here. So q of x is equal to x squared times 30 minus 2x. Make sense? I think that's the key on both of these is, you know, you just gotta solve for a variable and then plug in. Usually I'll solve for y so that I can get everything in terms of x. So this is q of x is equal to 30x squared minus 2x cubed. Q prime of x is equal to 60x minus 6x squared. Okay, and then set that equal to 0. Now I got a factor. Okay, so this is 6x. Okay. And then this is going to be 10 minus x equals 0. And so x is equal to 0 or x is equal to 10. Okay, so maximize this thing. Okay, so when x is equal to 10, well, then what's y? Well, y would be 30 minus 2 times 10. So y would be equal to 10. So what would be the maximum of this? It would be 1,000. So 14 would be 1,000 is the max. Okay, why? Because it's 10 times 10 times 10. Okay, 15 is done the same way, except this is y equals 6 minus x, and then plug this in for y. Okay, and then take the derivative. So when you do that, you get x equals 4. Okay, so let's do 15 here. Okay, so q of x is equal to x squared plus 2 times 6 minus x squared. Okay, we could take the derivative of this. This is going to be 2x plus, this is going to be a chain rule. It's going to be 4 times 6 minus x to the first times negative 1, and then set that equal to 0. And then you just solve the equation. This is going to be 24. Okay, this is going to be negative 24. This is going to be positive 4, so we get 2x minus 24 plus 4x equals 0. This is 6x equals 24. So x equals 4. If x equals 4, then y would equal to 6 minus 4, which is 2. And so then I would get 4 squared, which is 16, plus 8, which is 24. So q is equal to 24. Okay, max. Okay. Does that help? Make sense? Okay. Sounds good. Sorry, I got to get rid of this calculator. It's slowing everything down. Okay, any others that you'd like to see? Okay, 19. It's 19 here. Okay, for this guy, delta x is equal to this and delta y. Find delta y and f prime of delta x. Okay. So delta y is equal to the change is f of x2 minus f of x1. Okay. So this is going to be, okay, x1 is going to be on my original x value. And then the change, so we're at -4. And then where do we go? We go down. The delta x is how much we change. So I'm going to add -0.1. I'm going to go down. Think of it as a number line. I'm at -4, and I'm going to go down -0.1. That's going to be -4.1. Okay, so this would be x1. This would be x2. So delta y is equal to f of -4.1 minus f of -4. Okay, so I'm just going to plug, I would plug these values into my function. Okay, so what's f of 4.1 negative is -4.1 squared plus 8. And then f of -4 is equal to -4 squared plus 8. Okay, so 4.1 times 4.1. 4.1 times 4.1 is 1681 plus 8. It's 2481. So this thing is equal to 2481 minus, okay, minus 16 plus 8, which is 24. So that's just 0.81. So delta y, the change in y is 0.81. Okay, now what's f prime? What's f prime here of x? Well, f prime of x is equal to 2x. So f prime of 4, or -4, is equal to 2 times -4, which is -8. So that's f prime is -8. Now what's delta x? Delta x is equal to -0.1. And so I'm going to take -8 and multiply by -0.1, because that's what this tells me to do here. And so that's going to be negative or positive 0.8. Okay, so f prime of x times delta x is equal to -8 times -0.1, which is 0.8. Okay, so f prime of x delta x is equal to 0.8. And these numbers should be relatively close. Okay, that's the whole idea behind differentials, is that they're relatively close numbers. Because what does this thing equal? This thing equals dy. So dy and delta y.